The workshop today is divided into two parts. The first part is a bit of history. So you know that most of the things that are now having a fancy name and so, they started very long time ago. And also the second part is about how can you prototype fast and what do you need in order to build something that's scalable. And I want to hear more about your stories, what you do. This is also some kind of engagement that we need. It will not only be one way. The last part, I'll be presenting some cases that we built over the past 2 years for different scales, different customers. One of them, by the way, is here in Armenia. So I will show it to you, like, to be the last thing. And then we can have a small discussion about this. But first, before going forward, I want to take 1 minute just to know your backgrounds in just one line about everyone. I want to know the percentages of tech, non-tech, senior, junior, everything. So we can start from here, actually, like from your side, we can start with you. So, and then go like this. So we can start with you, just your name, like just one line about your background, about AI, RAG, what do you know, what you don't know. Yeah. Just to set the ground for everyone.
I'm Maureen. I'm a very basic level junior data scientist.
Okay.
I'm currently studying. So, yeah, and my interests are in the intersection of deep learning and chemistry.
Cool, cool. What about you?
Hi guys, my name is Sledge. I'm just Mike IT from the previous age.
Okay.
So sometimes some people ask me about my T-shaped skills. So I have a broad interest, and rack systems is one of it. So I hope I learned something new today.
Hopefully. What about you?
My name is Nadek. I have a background in tech, I would say, initially as a product developer.
Cool.
Product developer, product management. 5 years ago, I made more of the shift into working with software development companies, doing marketing, sales, and some operations for them.
Cool. What about you?
I'm Mohamed. I'm also from last century. Doing building software from last century.
Cool.
So, very short, I used to work at AWS some time ago, then moved back to Armenia, teaching at American University, cloud computing and software engineering, doing startups for last 6-7 years. Right now, what we're building is a hardware platform that can be used to build AI-based robots.
Oh, interesting.
Yes.
Very interesting.
Cool.
And you, Mohamed?
So for the last 10 years, I'm leading Groktalk as the CEO. Before that, I was a software engineer, and before that, I was a physicist. So we're focusing mostly on B2B, fintech, real estate, energy sector software, working with startups from all over the world, mainly from the United States, Silicon Valley. And yeah, currently exploring AI and doing a lot of new things in AI and low-code, no-code solutions.
Amazing.
After this intros, I'm like just software engineering graduate, but thanks. I'm Ada. I'm more in sales now, and I want to use AI with sales, so interesting. Let's see.
What about you?
I'm Ilya. I was working as a research engineer in computer vision for 15 years now, so I have understanding of AI, machine learning, and deep learning, but I have very basic experience with NLP, so I don't know about rack systems, and will be very interested to learn.
Amazing. What about you?
Yeah, I'm Liana. I'm NLP specialist. So I have experience around 3 years, like NLP essence. I've dealt with rack a little bit, but I'm interested to learn more.
Cool. What about you?
My name is George. I'm Syrian Armenian, and I'm freelancer.
Oh, cool.
David, I come from finance, my previous experience. Then I moved to IT in operations, then product management, project management, related to financial platform product. Now working with a startup, again, finance related, and looking forward to learn these RAG systems and fine-tuning the models in order to get going our chatbot.
Amazing. I guess you'll find a lot of things here. So, what about you?
I'm Devon. My background is tech, software development. I'm involved in several companies as a co-founder, one of which is software development company. Another one you might have heard, Skylabs, it's crypto terminals in the other one.
Okay.
So for the AI part, I'm just interested and curious to get into it.
Cool.
Armin, I'm international monitoring evaluation consultant. Currently, together with Mohamed, we founded a startup that's going to change the world of NLP.
Thank you. What about you?
I'm Norvik. I'm an NLP engineer at Ucraft. And currently our main focus is on generative AI models, large language models. We have a simple ROC system, and that's it.
Amazing. What about you?
I'm Joseph. I have a computer science degree from the American University, bachelor's degree. I'm also getting my master's degree too soon. I'm an AI engineer with Norvik at Ucraft. And during I'm interested in deep learning, ML, NLP, during AI. بتكلم عربية كمان.
Oh, جميل. أهلا.
Okay, hello everyone. My name is Isabella. I'm coming from Enterprise Incubator Foundation. I'm a tech enthusiast, not in tech background. With tech background, currently we are working on different projects connected to AI, and I want to get more involved in AI, and especially your topic sounds interesting, so I want to discover it for me.
Great. What about you?
Hi, I'm Anush. I'm PM here at Groktalk and helping to organize this event.
Thank you.
PM like product or PM like project?
PM like product/project. PMMP.
Okay, so let's start with a small bit of history. Some of you may think that RAG started last year or 2 years ago, but actually it goes back to the 80s. Most of the technology that we use today have roots in the 80s. Some of them are actually algorithms that was actually existing in research in the 80s and 90s, but we didn't have funding, compute power, or data to actually use them. And these things were just revived by Meta and Google and so on, and now they have more fancy names. So the first things were built, there is something way before Google, what's called Ask Jeeves. It's something like the paper clip that you had in Windows XP for the guys from the last century. This is, by the way, also a RAG system, more or less, but without the R part. So it's just without the G part. But the idea of information retrieval in general exists in the 80s. Guys who are also who got their degrees a little bit early this century know it as information systems. Like there was a specialization in computer science degrees and so called IS and CS. So IS is basically what now evolved to be NLP and so on. But the idea even existed and one of the most popularizing times for it was the Jeopardy bought by IBM that were able to answer the questions and beat humans and so on. So this was like 2017 or 2015 for the same idea. But the whole concept is the same. It existed many years ago. And it's all about information retrieval. So this is the core concept. You will find, I'm getting you, by the way, these diagrams are from papers from the 90s and also the next 2 slides. And when we go to diagrams and things that we have from this year, you'll find basically the same, but with different names and more updated technology. But the same concepts remain the same. So what people do in information retrieval is trying to find any relevant material to them based on a kind of a user query. This user query can be your web search, can be your prompt to ChatGPT, can be whatever you want to search inside something. This is the user query, which today we call it the prompt. And usually you try to do this information retrieval through some kind of unstructured data or semi-structured data. Let's say you want to search in a video, you want to search an image, you want to search in some web links and get the relevant ones. All of this is considered web retrieval. And it has 3 parts. I'm showing this diagram just to show you how later the same 3 parts are still the same. You always have an information need, something that we want to search about, talk about, to have some info about, we have a query which tries to describe the information need. So one way or less, I'm trying to form my information need into a query, and I know that this information need will be answered through a document. So this document is a place where I try to match my query to part of the document, hopefully not the whole document, but usually you want to have, let's say, a cell in Excel. This is the very basic part of information retrieval, where you can just, okay, cell A13 or something, but a document here in information systems context usually refers to something like, for example, documents, PDFs, JSON files. They're considered more or less unstructured, videos, music, and so on. So let's make a little bit of zoom just to see how the main parts of an information retrieval system looks like, and what are the missing parts. That this is, by the way, was how people built information retrieval systems, including Google and all of these, and the Clippy also from Windows, from, let's say, the 80s up to last 2 years. And we'll try to find where the gap is. So usually you have some way in order to index your data. You have a lot of data, unstructured. You can't really build a database for them. There is not really a way like SQL database where you can put tables and structure your data. So you need to find a way to index this data. Way before the current days of LLMs and so, you had to do some pre-processing. That is the first step. So you have to make the text clean, basically. Currently, this day, you can open ChatGPT, throw any PDF, you'll get your answer. Back in the days, we had to spend a lot of time understanding the document, the structure, what to remove, what to not remove, and so on, in order to basically increase the probability of finding good words and remove any word that, let's say, in English, you have a lot of stop words. For example, you have the, and these words, if they appear a lot, they will basically be noise and will allow us not to find better information. Things like stemming, you have, let's say, teach and teacher and so on. We try to make these things together. And then you have the modeling. How can you retrieve text? For example, one of the most famous parts in this, how can you build something like PageRank, the algorithm that Google made, and it was very revolutionary. Till now, you can make the same thing with a normal agent, let's say. Like one of the agents that you can build in 2 days can do the same as Google with some crawler. But at the time, it was very revolutionary for them because it allowed ways of unstructured retrieval. You can just crawl pages and so, and try to give them some ranking. And after this, you do the indexing, which is actually the most messy part till the current stage, which is how can you build some way to search around this data. In SQL, let's say you have some kind of table and rows and keys, but in unformatted data or unstructured data, it's very hard to navigate through this. So you have to invent a way of indexing, and this was actually, and still by the way till today, the most important part on how you build your retrieval part. And then you have, after doing the indexing, how can you retrieve this data? So you do some kind of search. Maybe you do it with a search keyword, you do it with Boolean input, you do it with keyword matching. Sometimes you do it, as you will see, with probabilistic matching. So you match a word by their frequency or probability and so on, which now, by the way, the techniques are the same. And you will see as we move forward, the techniques that were used, I would say, from 2013 till today are the same. We just have more data and more compute power to crunch more data and get more accurate models. But the core idea is the same. The same calculation, let's say, or the same algorithms that are used on the high level are the same, but now we have the computational and data abilities to crunch more numbers to get more accurate probabilistic models in order to retrieve this data. And then this is the part related to the retrieval, and then we have the part related to the user input. We used to have a problem back in the day. I guess all of you noticed this when you go to Amazon, to Temu recently and so on. You want to search for something, so you have your query in text, but then you have to add more inputs. So these inputs are like filtering by size, by price, by whatever thing. So this query formation part and query processing is how can we take text and some structured input in order to search inside our database. Because searching by text only is very inefficient at the time. Like you can just match and so. And back at the time also, like another topic but also relevant, back then product recommendation systems were very naive compared to what you have now. So in order to construct something like this, it was very hard. You would find, by the way, for this part, it takes a long time till today, till the recent version of Windows, and even in MacBook, to search inside files. It's an information retrieval system. You have your query, and then it asks you, like, do you want to search on a specific folder and so? And then you have this green annoying line trying to like index the data because they do it on the fly. Recently with Copilot and so, things are a little bit easier, and then finally you find the answer. We can see here we have one big gap is the answer is provided as is. You just have some links, you throw them back in Google, you have some files, you throw them back, but there is no way to make use of this except showing the data, and then you have to build something else in order for the answer to be made useful, especially with unstructured data. Let's say if you have some kind of structured data, graphs or numbers or so, you can build a dashboard. You retrieve your data, put it in dashboard, and that's it. But let's say you have few PDFs. Let's say you have few videos or so. There is no way I can make use of what I retrieved and produce new content, basically. So this was the main problem that made these systems known by many names. Let's say information retrieval, information systems, data mining, name it what you want. They're all more or less the same. And the main problem is how can we make sense of data just to move forward. And you'll find every single idea here is actually from 200 years ago, 300 years ago. You know, they got more fancy names, but the ideas in the same are basically the same. So what we have here, the first step in order to make this a little bit more efficient is try to understand the semantics of data. Because my main problem here is I can understand the syntax very well. I can build queries against static data, more or less, but I have a big problem in understanding the semantics of data. So we will try to figure out some ideas. The first one, this one, like the standard Boolean, extended Boolean parse, this thing is what you use in Amazon and similar websites when you try to filter by size. Just in the background, build a condition based on what you are saying. And even you can go to things like Elasticsearch, the older versions, which allows you to make more or less like near to normal or natural language query, and then they transform it into some kind of full text search. And then you have the second part, which is the algebraic part, which you have the vector spaces, you have the topic-based vector space, and all this family, which today we know them as embeddings. By the way, it is the same idea, but now we have the ability to crunch trillions of tokens instead of just having a database which is like a 20 kilobyte CSV file. So this is the main difference that we have. And the last part, which failed actually in providing value, but now it's mixed with the algebraic approach, is trying to build probabilistic models by hand and using these probabilistic models, like inference networks, for example, to retrieve documents. By the way, the inference networks have been used to build RAG systems since 1989 in a paper released by MIT. I'll show it to you the next slide. The whole concept was done by this, but the human operator needs to build the index for their database. So in order to make it for a new database, you have to build a new inference network, which later became belief networks. And they're not related to neural networks, by the way. It's just a name. But they have the same idea, basically. So based on this, we found 4 main problems that makes us not able to work with any kind of, let's say, a full-fledged information retrieval system. The first part is we can build vector spaces. We can represent our data as some kind of a mathematical, let's say you have text, I can present it in some kind of a vector space, but it's hard to capture the semantics on a very large corpus. You can work with vector model. It's still used today in some hobby projects. It was released in 2013. And it's very old, but this has very, it has a lot of limitations, especially that works on word level. Later, there is also sentence to vect, and there is document to vector. Same idea, but they all fail when we try to crunch bigger documents in order to capture more semantics about language and so on. The second problem is you can build probabilistic models. As I said in the inference networks, it has been used since 35 years. I even put the paper title here. You can look it up. But the same problem is you can't construct them to be general. If you want to do something, let's say for finance, you have to rebuild the whole thing again for accounting, for whatever, and so on. And the third part is it's very hard to make natural language queries over general tasks or unknown tasks. This is the most important problem that we have. For every task, you have to fine-tune your older models, random forest models or Ngram models, and so on, to be for this task. So before 2018 or 2019, if you wanted to make a summarization model, you have to build a summarization model from scratch. If you wanted to make a classification model, you have to build it from scratch. Today, most people, me myself even, we became very lazy. We just throw whatever we want at our model, whatever the model is, and we expect it to do this, to do this task. And I will let you know why it does this actually. And the other thing is there is no general or efficient way to generate data based on the retrieve text. I can have the retrieve text, but I don't have an efficient way. There are, by the way, many iterations or trials to build this, but there was no efficient way to do it in a general. Like you can have this, and everyone can plug it and play. So this actually changed in 2017, 2018, when transformers and the attention mechanism was released, which divided the way we build models into two parts. The first part, I wouldn't go too much into transformers. It's a much bigger topic. But just the idea that changed everything is now we can use the same model in order to do the representation of our data. We have a decoder module which allows us to represent all our data in a compact format, and it can process very large data sets easily and also computationally efficient. And we can attach it to another generator, let's say, or decoder and encoder. And we can use the decoder to generate new things based on the input that we have. And later, as you can see in the few years after it, we have the encoder only things like BERT. Maybe some of you work with it. We have the encoder-decoder architectures. And today we have the decoder-only architectures, which are what we know now as LLMs, or what we're now popularized as LLMs, even if everything that's a transformer is more or less an LLM. But what people use now in Claude, in Llama, whatever the thing, are this part only. And you have another model doing this representation for them, and we use it to generate new text directly. So this was the main core idea that changed AI forever, because the same idea is now used in vision. We will talk later about even multimodal systems, where you can throw whatever data you have and have it explained by the same architecture, because this architecture can work with text, images, video, audio for the same part. And then just, this is history. We all lived these, we all tried most of these models. So I will not go in deep. Actually, all of this is old now. This photo is from 6 months ago, but it's old already. And we just need an intro now to go to, actually, now we are talking about LLMs. We need to connect the pieces. We have LLMs that can generate cool stuff. We have the information retrieval system, a very well-established domain, but we need to connect it with AI, more or less. So LLMs give us three things that we can use in order to build better information retrieval systems. The first thing, which is, by the way, questioned by the scientific community, is something they call emergent abilities, which is today's alchemy. This is not science, this is nothing. But everyone is having this speculation that if you put a lot of tokens and a lot of layers and a lot of compute power, LLMs can do tasks that they were not trained on. There are papers from different companies proving and disproving this, so this is not science by any means, but what we have now, at least on our small scale, that you can have the same model to do multiple tasks, even if it was not trained on this task. Let's say the model can do a task on summarization, but it didn't have in the corpus summarization data. What they say about it is that with a lot of tokens, the models are now able to build almost complete models of languages that they use. But I'm very skeptical about this, but it works for now. The second thing is the ability to have feedback mechanisms. So now we can rate the answer that we get out of the LLM. You can say it's good, it's bad, and this ability to rate is very old, but the ability to use this in real time to update the models and train the models is the new thing, which was popularized by OpenAI and ChatGPT and now in other models. And the last part is the ability to customize your natural language prompts, add more context to them, which now we call prompt engineering, which again builds on the same idea that this model has trillions of tokens or billions of tokens, so it can do new tasks if I wrote a crafted, good, let's say, text to it. And now many people are building applications, putting it to production with an OpenAI API and a good prompt. And they just work on the prompt for 2 weeks, they have something good, and they respond with it. This will not continue for long, but it's now working. Like people are making business out of this, just with the ability to build good prompts. And actually, on the other side, people are becoming more lazy in their prompts, so they expect to just type anything that it will be done. So it actually makes you easily detect AI-generated text and AI-generated reports and so on, because people are also becoming lazier. And in 2020, the final piece connecting all of this came together, which was a paper from Meta. If I remember correctly, this paper was actually released by a team there. It's from Meta and Google. I don't remember the exact company, but they had this idea that we can add more data to the context of the LLM as you work with it, and this data will be used to train to make a new result. So what they did is they had this retrieval part, and this retrieval is non-parametric, it's not trained. So this part, no backpropagation happens, nothing is actually done here, it's just a database. What they called it retrieval in the paper, or retriever in the paper, is just what you call now as the vector database or whatever, with the model, of course, connected to it, and the generator, which takes the data and put it to, like in a new context, or generate something new based on the old data. So now you have the bases connected. You have all the what's called retriever in this paper or other papers is what we know as information retrieval systems, and this is the LLM part, and they just build connectors between them. How can I connect all of this into a format that the LLM can understand, and then train all of this together? This part is not really trained, but we can adjust how data is retrieved based on the performance of the model. That's why today you can use the same vector database and the same data with different models, let's say Llama, OpenAI, and so, and you'll find different performance, because each model is trained on different ways of vectorizing data and understanding them and so on. But with this, we had now a retrieval-augmented generation, which is the RAG part, which is now I can generate text, but I don't have enough context to include, let's say, all my documents and so on. So it's now retrieval-augmented. I just added a database in order to give more data or give more context to my LLM, especially that the LLM itself is very limited in its knowledge. Okay, like it's not up to date with today's news, let's say. But if you give it a link to scrape with today's news, it will answer about what happened in the US election, maybe. So based on this, now we can do 4 things. We can build vector databases capturing very large corpuses. Let's say ChatGPT or any other models are trained on the whole internet. They're trained not only on Wikipedia. Actually, today, this is a case I can discuss at the end. You can index the whole Wikipedia on your laptop, like just with a laptop and an efficient vector database. It's not a hard task anymore, but bigger models are trained on the internet, basically, so they scrap the whole thing. You can also build probabilistic models for retrieval and apply them to unseen tasks, which we have now. You can make queries with natural language, and you can generate the text in efficient, cheap, and accessible way. We'll talk at the end about that. Today, there are also a trend to run these models locally. So you can have LM Studio or whatever the tool I will be showing you, and you can run it on your normal MacBook. Even a 2020 M1 MacBook can run this, and you can get results for your business and so on. So this actually takes us to the second part, which what makes a RAG system. This is a very standard, very naive RAG system, nothing fancy here. You probably build something more complex than this, but we need to use this as our starting point. So in order to build this, you'll find the same modules from the old, much older diagram I showed you, but now they have different names. Like you have here a knowledge base, in the database. You have the weight or the mechanism to retrieve the documents, embedding to make modeling of these documents into some vector. You have the vector database to store these vectors in a searchable way. You have your LLM model. You have the user query, which is the prompt. You have the user, but if you did this, you'll find the modules are the same. You need a way to store and manage your data, the raw data. You need a way to parse this raw data, PDF or whatever, which is, by the way, by itself is a very big area of research. How to represent this data in a mathematical probabilistic way, how to retrieve and structure this data, which we called indexing. It's still, by the way, called indexing also. And how to generate the new text, and how to figure out, which is also a big part of advanced RAG systems, is how to figure out the user query correctly. This part, and the research in this part, is what allows you today to input anything, like very poorly written prompt to ChatGPT and get a good result from the other side, or at least an average result. So we will go through each component of this, and the next part, let's say the next 10 minutes, will be on how you choose this. What I will try to focus on is not the new or old technology. Everything I will say today will be outdated next week anyway. So I will not focus much on like a specific model or so, but what I want to try to do is to help you build a mental model of how can you build your own RAG system. At least prototype it very fast, as I will show you. And for guys who work on NLP already, how to take this to production, what are the main problems that you usually face, and so on and so on. So this will be just to set your expectations. We're building a mental model. Details that are explained here, if I mentioned a specific model name, it may be a little bit outdated by 2-3 weeks. Things are moving very fast. And also, it may be like now less efficient than the benchmark I'm putting now for this. So the first thing is choosing your embedding model. The embedding model, the first step is how can you take the text, the raw text, and transform it into some mathematical representation capturing the semantics of the language. I'm having the BOM, so this embeddings will relate the BOM bars together. You're having some PDF, it will relate, okay, they even have this famous diagram, it's like a man plus king minus woman is queen, something like this. So you can make operations on text and so on. So we have few types of vectors. When the models generate something, they generate few types of, like you can have different models with different things. Some of these models are old, by the way, so don't take this as something as a fact. So we have a sparse vector, which is a vector of like a series of numbers, but it's mostly zeros. It's trying to capture some part, and this is used for sentences, to capture the main parts of a sentence. You have also the dense vectors, which again used for sentences, but now they're capturing each word. So each word in the sentence is part of the vector. You have also the multi-vector, where each sentence is represented by a group of vectors, which is now a matrix or a tensor. Let's say you have a big paragraph, you don't put it in one vector, you build a tensor for it. And you have the long context dense vector, which these ones are now used for retrieval by things like ChatGPT and Claude and so, where you can retrieve a whole page or something like this. And the vector captures the whole meaning of the full page. And you have the variable dimension. This can be, this is used when you have multimodal data. Let's say you have some images and so. So if you want to encode an image, it will be, let's say, a smaller vector. If you want to encode a PDF file, it will be a longer vector, and so on. And you have a special type of this for code, not only for code, but things that are similar to code, which is how the data of code is semi-structured compared to natural text. So with the way to build vectors for them will more or less change. And as you can see, there are some models like this one that repeat even for the same task. It can do multiple tasks. Second part is what is the data I'm working with. I guess most of you have seen, people who work in tech more, you have seen some tutorial on Medium or any newsletter that you can now talk in natural language with your SQL database. You can just write text and get it back and so on. So actually we can work with structured data and unstructured data, even if it's more famous to work with unstructured data due to, okay, everyone can build a database and we can optimize a good query for it and that's it. But people also prefer to work with unstructured data. So unstructured data can be text, PDF, websites, videos, images, and so on. Usually, if you are very lazy and you want something reliable, you just use S3, throw all your data, figure out some good glue code around to query this PDF well, and have it working at least for a prototype level. If you want to go a little bit to an advanced level, you can use something like Databricks to build a real data lake, which allows you to efficiently classify and index all your files and access them in an efficient way for parsing, which is the next step. On the other side, if you have structured data, you can use Mongo, you can use Postgres, SQL, NoSQL. Recently, you can also use Graph Database, which I will also be talking about them at the end. There is the GraphRag by Microsoft. You can use even older technologies like Neo4j, which has been here for, I don't know, a decade maybe. And you can use it also for the same idea. But graphs, tables, and so on, they are all structured data. You can navigate them with well-known algorithms that you study in the first or second year of college. The next part, after choosing your data, all of this is easy, more or less. You can easily navigate through it. But the harder part is actually how to parse this raw data, which is an unsolved problem. Many things you'll find here, and more even, try to just figure out how can I parse a PDF efficiently, and figure out what's important or what's not. Just to give you an idea of what's happening, we have 3 Chinese companies here and 2 American ones. The Chinese are doing very, very good work in this part. Not only in Chinese, but the OCR, for example, can do OCR in Armenian, Arabic, English, Korean, whatever the thing, without training. We deployed projects in production with this without doing any fine tuning on BDF and different things. DeepDoc and RagFlow are the same idea. They are built more for RAG. And you have Llama Parse, which is the most famous and most efficient now. It's free also, mostly. And unstructured, which is also, like you have a free tier you can use for prototyping and so on. Then you need to choose the vector database. You extracted your data using this, you put it in the database, you got a middle model. How can I choose a good vector database, which all of this mathematical representation will be put inside it? There is actually this diagram, which I can show you some things here, and there are real comparisons like this, where you build a sheet like this, trying to figure out which database to use for which thing. Some of the data here, that's why I will not focus on it, may be a little bit outdated, so I will not go in detail about it, but we can just focus on the 4 aspects that I choose in order to choose my database. Currently, and similar to what happens normally in the database world, we have the big players, and then we have a lot of people trying. So in the vector database world, we have also a few big players. I will show you in the next slide. And when we choose this, we focus on 4 parts. The first is the performance. How performant is this database? About the data freshness, how much I can do update to the data. And this is also for people who work with databases. This is a read-intensive database, so I need to choose a database that scales well in read operations. Second part is the query latency. How much does it take to give me back my query, and in which scale? And if there is parts related to concurrency and so on. Namespaces and how we structure them. The relevance, which is how good, this is different than performance, this is more accuracy, how good it can retrieve my data. As the term of accuracy, does it support things like metadata filter, which can not only filter the file content, but let's say name and date and other metadata you can provide, and whether you can do live index updates or not. For things like web scraping, where people are doing things like web scraping and so on, it's very important to have a live update on the database while working with it. If you're doing something like resume search, which we built also, and you have, let's say, 3,000 CVs, you want to filter which is best and rank them in real time. When someone sends a CV on the email or your ETS, you need also to have live index update, because you have to re-index all of your data and refetch the good ones. So you need this part. And scalability, it should basically, you just need to know how much will it cost. And I'm focusing here on cost, because scaling these databases are easy. Everyone now is building them over Kubernetes or AWS and so on. You can scale with a click, but the idea is how much does it cost to scale, and when do you need to scale? So I can now in 2 minutes deploy a quadrant cluster on AWS with 2 clicks, but then you need to calculate how much clicks it will, how much the limit will be for concurrent users or for concurrent queries after needing to, let's say, build something more efficient. And also the vector limit, how much it can store in the same index while maintaining the efficiency for it. Because if you store a lot of data, it becomes noise, so you have the same problem, which is not appearing in the normal databases. In a normal database, if you have millions of tables, you just have to work more with the performance, but you will get the data correct anyway if you build a correct query. And the last part is the cost efficiency, which I'll be talking a lot about, because one of the I would say the biggest mistake everyone makes, we even did it in the early demos for clients and so. You can build a demo very efficiently, you can build a demo very fast, everything is free. Try to build this into production for 100 plus users, it crashes. The cost becomes unmanageable. So while I can make everything here easy, I need also to see how much I save and so on, because actually while you can make few things on your laptop without a lot of compute power, it takes a lot of cost. So you can see here, for example, for different databases, you have Weaviate, which we have Quadrant, which is the free version of it. You have MongoDB, Melvus, which is my favorite, by the way. ChromaDB, which is local, in memory, you do it on RAM. Pinecone, which used to be a superstar when they partnered with OpenAI 2 years ago. Now no one uses this because they didn't offer any way to use it for free. So you had to pay money for them, so they were just pushed out of competition. For guys who already have, let's say, something in Postgres, you can use BG Vector. While it's not very efficient, but it doesn't make you design something from scratch. So it can be also a good thing. You can use this diagram and similar things. We can share it with you after the call email as a guidance. But usually you need to do your cost calculations. You need to, because some of these databases will more or less have updates. For example, you have this like how many queries per second they can do, and so on. And the second part, I chose a good database. Let's say I have something cost efficient, everything. I need to figure out how I will search inside it. These are the three most basic methods to do this, but there are even things that combine structured and unstructured databases together. But as a basic idea, we have a keyword search, which then we pass it through an algorithm like BM25, and then based on it, we try to get the nearest document. We have something which can be not with a direct algorithm, but with an LLM in between, encoder, or even something older like BERT or something like this, and then pass it again through the vector database to get our documents. And we have hybrid search. Hybrid search is actually not limited to the BM25 and by encoder, but it actually includes a very big family of algorithms. You can use 3, 4, 5 algorithms. Something, for example, one of the things that was very interesting to work on is using Elasticsearch with S3 to query data from both sides. And you can use, actually now even Elasticsearch provides something to allow you to do vector search on their indexes that you already maybe have been working and scaling on easily. And you have LLMs. I will not go much into this. This screenshot from the dashboard was taken today. If you open it tomorrow, you'll find everything here except OpenAI changed. But this is just to show you have a lot of work to do here to choose your model, which compared to everything else is the least part to work. If you have a model that you trusted, you work with it for a few months, you don't need to change it every week. This is also because people can get overwhelmed by the changing models. Every day you have a new release of something. You usually don't use to change the model. We have systems today in production, they're still using Llama 2. Llama 2 was released last year. And they're performant, they're fine. The client don't want to change it. In other systems, maybe it's also good to catch up with what the research is doing to get some performance, but it's usually good to consult. This is, by the way, chatbot arena. You can get like live updates on what model is doing what, and compare them even in the website and so on. And final part, which most people do, is prompt engineering. Most people don't use all of this in their prompt engineering, but more or less you can do a lot of techniques after you build your database and everything. You need also to build a good prompt, both for the retrieval model, or what model will be retrieving from the database, and also for the generation model, in order to generate high quality responses. There are many techniques. The most famous of them, actually I will maybe talk about 2 or 3, but the most famous and the easiest to implement without a lot of technical knowledge is chain of thought and the family of graph of thought, tree of thought, and so on, which you try to make the model think in steps and produce like semi or partial output and use it to iterate more. By the way, it's a simple in technique in concept, but you have companies like OpenAI, they did O1, like ChatGPT O1 or so, with this, and branded it as brand new technology. It's just a chain of thought, nothing fancy to do here or to have here or whatever. You have you have things like React, which and also the ART, automatic reasoning tool use, which today people call them agents. Just the model is able to deconstruct your query into some kind of, let's say, I have an objective, what actions to do, what tools to use. So this is how today, for example, you can use web search while searching in Claude or ChatGPT. You can use some summarization. If people who use ChatGPT to generate code, can generate code for you and run it and give you the result. So you don't need to write the code yourself and so on. This is the tool use part. Now we can enable through, also the model needs to be trained on this data, but you can enable models to use real functions, normal functions, those programmatic abilities, and interact with the outside world. So these are some of the techniques. I'll also leave it for you because each of them maybe need a lecture by themselves to explore fully. But this is the last step, and actually for most of the systems and for most of the non-tech people, this will be what you will be trying to play with and building something more simple. But you can get I would say average, above average results just by prompting. And then later you can, let's say, pass it to an engineering team or something to build the full thing for you or to scale it up. So this is like just to summarize and to move from like what we discussed in the last part is what makes a basic RAG. This is like the basic components to build a RAG system, which after all of these diagrams will be into indexing, retrieval, generation. This is more or less the idea, the thing. But if you want to build a real RAG system, something like this, you have a lot of things to do, just in the retrieval part. Indexing part, by the way, can more or less fall into the umbrella of data engineering. So the tasks inside, the way you think and so on, it's more about databases and so on. Usually, current AI engineers don't like it because it's not AI. It's just data engineering. People who work more, let's say, from the days of Hadoop and when it was called big data, will do this better and more efficient, and also abiding to the industry practices. So a normal AI engineer may not know about, let's say, sharding and replication and so on, but someone who does data engineering or big data knows this very well. So we'll just focus on this retrieval part more. So you have to do things before retrieval, like pre-retrieval, which like you have to, the user will input whatever low quality text, you have to make it into something more real. The data is looking not good, so you have to change it in something better. The indexing of your data, you have the retrieval with search, ranking, and even the post-retrieval, which we have a technique for, it's called re-ranking, where you, after you retrieve the chunks of text, you make another ranking or another scoring ground for them in order to make them looking better or as a result. And after all of this, you have the generation. Most people think when they work with RAG is the most effort is in generation. This is the least effort. Most of the models now are open source. You can run them with Olama or like, I will show you like in the free tier of Grok or whatever, OpenAI key or OpenAI compatible key, one line of code, you have the generation part ready. It's not what you think about. What you need to think about to make a good RAG system is actually all of this. And we will see as we go more far, there are more ideas and more details to cover in this. So we have basically three paradigms. The lighting here is not good for it, but like the idea, we have three paradigms for RAG. The first is the naive RAG, which you'll find most people able to build it in a few days. You have the advanced RAG, where people are able to add something like pre-retrieval, post-retrieval, doing or adding more ideas. And by the way, the pre-retrieval and post-retrieval is what people try to do in order to make benefit of older NLP techniques. So let's say you have things from the days of Word2Vect and Spacey and so on. You try to use it here to make the advanced RAG. There are also techniques about search and so on. I will try to cover one or two of these techniques as we go forward. And we have the modular RAG. The modular RAG is different ways to build RAG systems, because there is also one direction, which is again is prompting, or the chat interface way of getting data. There is also some idea that people want to build these systems in a way more or less is similar. I don't know if anyone here is having some electronics background or so, but it's how we build things in Simulink or LabVIEW or so on. So to make it blocks that talk to each other back and forth till you get the output out of it. So the modular RAG is just, advanced RAG is too much now in the modules that they have and things. And now, which is good by the way, is one of the things on the other side, the software engineering failed in, like the normal software engineering failed in, is easily and very fast standardizing the whole industry. Now we have basic blocks. You can just mix and match whatever model with whatever embedding model with whatever database and build a pipeline. So this is the idea more or less behind the modular RAG. So after all of this, we did all of this thing and we didn't till now actually talk about how we will implement all of this. So we still have two things to cover. The first is how to build RAG very fast. This is more towards non-tech people and tech people who want to build something to show to their managers and gain value fast, like to prove value fast in 1-2 days. And it's good up to, I would say, some like medium production level. Like if you have few tens of users, it's fine. After this, it will be very costly actually, but you have these tools. I just bought here 4 of my favorite tools. This is a biased choice, by the way, so don't take it for granted, but you have LangFlow. It's one of the tools allowing you to build agents and RAG pipelines very fast with drag and drop, something like this. And the good part about it is you don't need to write code to pass things from, let's say, Google Drive, or to, if you have a lot of files here and there in database, they provide most of the connections, which is the part that most AI engineers hate, needing to work with data or to handle data, especially after many years of everyone being like programmed to have a CSV file, especially NLP engineers. DeFi or DeFi is actually something more sophisticated. This is something that you can use, and it's used, by the way, by places like Airbnb and so, to deploy production applications. The best part about it, it generates code for you, actually. So it generates the code that you can later put it in production, LangChain code, so you can get it out and start working with it. You have N8N. This is more biased toward business automation, RPA, and similar ideas. If you want to build something very fast, but you need to add the AI component, and you are, let's say, in accounting, finance, telecom, like not an engineer, this will be good for you. And LLM stack, it's still new, like it was released a few months ago, and this is focused more towards agents. If you want to build things that, let's say, crawl the web or do something like this. This is, by the way, from N8M. As you can see, it's very simple, like as the blocks and so on. And for people who worked also like earlier with data, it's similar to a tool called KNIME or K9. If maybe some of you work with it. And this is DeFi. You can see here, like you can build actually conversation flows and so on, which can be like to build a conversation flow is not hard, but to build it in code can be boring. So this way, it's easier to prototype, and it's easier also to make. This is why I prefer it for prototyping. It's easier to make your business stakeholder part of the process. Sometimes, like I'm working in AI, but I don't have experience in all the domains I work with. And I need to consult the subject matter expert a lot. So this way of visualizing things while hiding details is good, and later you'll transform it to some real thing. So, are these tools actually bad? I would say no. This is my opinion, just for one reason. The reason is, okay, they may not be production ready, but most of them are open source. You can use them in your laptop, you can prototype fast, you can get value fast, and this is needed in the current age, at least in the current, let's say, 1 or 2 years. I have a very skeptic idea about no-code tools. Actually, I'm working currently on one for the past 4 or 5 years for computer vision. And usually no-code becomes low-code and then an SDK. You have to write code at the end. You just can't avoid it. Look at every company who tried to do this no-code thing. You just you just end up by writing more code at the end. But it's good for prototyping. It's good for delivering fast value to the customer, so we shouldn't reject it. But also, maybe the negative part of this, for engineers, it can build some bad habits. So it can build some bad habits regarding how you think about your system, how you structure it. When you do something like this, usually you don't care about scalability or so. Especially if you're using the cloud version, you think, okay, like Langflow will handle it for me. I don't care. Like this is the thing. So it's not like, maybe it's not the best practice or the best thing to be dependent on them, but it's the best to actually deliver value fast from this. Especially with the current atmosphere that we have, there is a big hype for AI. And also there is, which happened in the 80s and so on, there is also a possibility for an AI winter. So if business stakeholders, which we have a lot with here, they will see from us on the other side of the tech some value in the first, like 1 or 2 next years, all our teams will be like,